_main, the layout file. The first thing we're going to need to do before being able to display any of the tasks is to actually allow the user to add tasks. And this gives us a chance to show a new Android widget, something new for our Android toolbox. A very popular way to display a single primary action on a page is with a component called a floating action button. It's pretty much just a button, a special button. It can have some elevation. It usually has a nice colored background, is a sort of square or circle or sometimes a squircle shape, depending on what version of material you're using. And it's a thing that a lot of Android users are used to. It's a common Android pattern. And there's really not much to the layout code. So underneath I've got ViewPager 2. We can do with a capital F, floating action button. And you'll see there's two, the floating action button and the extended floating action button. We will focus for now just on the standard floating action button like that. And for now, we'll set the width and height to be just wrap content. So wrap content and wrap content and a self-closing tag. And if you look to the right, you can see we have in the top left for now this floating button. There's a bit of shadow on it. It appears to float above the toolbar. Of course, we want this not to be at the top, so we'll put the appropriate constraints on it. So we want to go bottom to the bottom of the parent, end to the end of the parent, as the bottom right is the common place where users are expecting to see this button. And we want to give it some margin, so we'll do margin, just the normal layout margin for all sides, something like 36 dp. Yeah, I think that's okay. You don't want this button to be too close to the edges. You want it to stand out a bit. So a nice floating effect we have there. We should give it a custom icon. So resource manager, new vector asset. I think just simply add will be fine. So top left, the simple plus icon you can see there, add. We'll make this our icon add drawable. And then in the floating action button, we can do src and then icon add. And if you look to the right, that will be okay for now. Yeah, a simple plus icon. We can do src and then icon add. And if you look to the right, that will be okay for now. Yeah, a simple plus icon. We should give it an ID. And I often see if there's just a single floating action button in a layout, this get abbreviated to FAB, floating action button. Feel free to follow that convention or do a full name if you want to, entirely up to you. I'll close the resource manager actually. Okay, so we have a floating action button and we can head back now to our main activity and do something with this. So we'll do a simple onClick listener here. So binding.fab.setOnClickListener. And we will later on make a nice bottom dialog, a sheet that comes up from the bottom of the screen. But that's a new concept and we don't need to know about that in order to start working with databases. So we'll do that one later. So for now, we'll just do a simple material dialog. So we'll do material alert fab.setOnButton. Feel free to follow that convention or do a full name if you want to, entirely up to you. I'll close the resource manager actually. Okay, so we have a floating action button and we can head back now to our main activity and do something with this. So we'll do a simple onClick listener here. So binding.fab.setOnClickListener. And we will later on make a nice bottom dialog, a sheet that comes up from the bottom of the screen. But that's a new concept and we don't need to know about that in order to start working with databases. So we'll do that one later. So for now, we'll just do a simple material dialog. So we'll do material alert dialog builder. And that needs some context. So this will do. And we'll do set title, add new task. We'll do set view, make this null for now. And then we'll do dot set positive button, save. And then our 2 parameter lambda that we don't need. And then dot set negative button, this can be cancel. I think you can just pass in null actually, as we don't really need a click listener. It will dismiss automatically. And then dot show. And we should just quickly make a binding for a simple edit text for now. So project layout folder, new layout resource folder. This can be our dialog underscore add task. I'm flying through some of these basic concepts like adding new files. Again, dot show. And we should just quickly make a binding for a simple edit text for now. So project layout folder, new layout resource folder. This can be our dialog underscore add task. I'm flying through some of these basic concepts like adding new files, new layout resource folder. This can be our dialog_add task. I'm flying through some of these basic concepts like adding new files. I don't want to spend too long now on the foundational stuff as we get into more advanced concepts, okay? And we'll give it a bit of margin, squeeze it in a bit, maybe 20 dp, something like that. Oops. And then I will do a text input layout, match parent wrap content, and inside it a text input edit text, match parent wrap content. Give an ID for our edit text, we'll need that. Self-closing tag, making sure to constrain this. Actually, we don't need a constraint layout, it's just a single view for now. I'll quickly change this to a linear layout. It'll be simpler, not forgetting orientation vertical, although I suppose it doesn't really matter with only one view, but that will be okay. Height will do wrap content, I think. No, we'll leave it as match parent. I think the dialog takes care of that. That should be okay. We'll just be sure to style this. The style can be a text input and then outlined box. There. I will give it a hint, and that can be just task. Okay, very quick and simple this. There's nothing fancy about this layout. We just need something basic to work with. If I head back to main activity now, we can, inside this onClick listener, inflate the binding. So our dialog binding equals dialog add task binding dot inflate. And we Okay, very quick and simple this. There's nothing fancy about this layout. We just need something basic to work with. If I head back to main activity now, we can, inside this onClick listener, inflate the binding. So our dialog binding equals dialog add task binding dot inflate. And we already have access to a layout inflator because we're inside an activity. So just layout inflator should work. We can set the view as a dialog binding dot root. And just to prove it's all working, we could show a toast when they click save. We can just say your task is, and then a colon, and then we can refer to the dialog binding dot edit text dot text. So then we'll do task view as dialog add task binding dot inflate. And we already have access to a layout inflator because we're inside an activity. So just layout inflator should work. We can set the view as a dialog binding dot root. And just to prove it's all working, we could show a toast when they click save. We can just say your task is, and then a colon, and then we can refer to the dialog binding dot edit text dot text. So then we'll do toast dot length long, give us a chance to see it, dot show. And being a good citizen, I should probably put this in its own function for now. So Control-Alt-M, we'll call this show add task dialog. Okay, so just a quick recap, we've done a lot of things there. We added a floating action button in the layout file. We pinned it to the bottom right of the screen. And then we set an onClick listener on it where we show a dialog. And we use the material alert dialog builder that we saw in the last section's challenge. We're inflating a dialog binding. And then when they press save, we are just simply displaying the task they added for now, as very, very soon we'll be looking at databases and actually saving this using the Android Room library. So let's go ahead now, run it to make sure everything works. works. No crashes, that's always a good start. You see we have this nice floating button in the bottom right, and when we click it, we have the material dialog. Yet again, the padding hasn't worked. Let me just go to the layout. Yeah, margin doesn't work. It's actually padding that we need. It's a real funny thing with the way that dialogs add the layouts, where margin just doesn't work. But padding will be fine, because that squeezes things in. So if I go ahead and run this again, okay, and that works fine. And then if I add some imaginary task and press save, well, then we get the toast. So this is the point where we can actually save it somewhere. Okay, so we've flown through the app setup there, but the fantastic news is we're now ready to start saving things in this app. And rather than using shared preferences, we're now going to look at saving more complex data, and the best way for doing that is using an app database. So time for us now to do a deep dive and first understand what databases are. We arrive now at a landmark moment in our learning. In this it's one of the be intimidating when you first encounter it. Conceptually, it might be hard to fully understand what a database even is, let alone how it works. And as it underpins so much in programming and software, it's a crucial topic to understand. So in this tutorial, we'll look to answer the question, what is a database? A database is an organized collection of structured data. It really is as straightforward as that. Action, analogy for this. New, each recipe with action. Right, well, the data, way that you may encounter, they will have many similarities to database, but document databases are quite different from relational. They're often used for different. To help us understand relational databases, I'm inside, well, anything from Moonshooter King. And that then leads to the possibility of human error. Now, when viewing in a spreadsheet software like this. And then it's called a relational database because in one table, you may reference the ID of a record of a row. We should have a pretty good grasp now of what a database is. In fact, so much so that I have a feeling if I say the words organized collection of structured data related to creating data, use site, creating various to the database's butler to say create this data records or delete them from the Android, where we'll learn. We head now straight into the first of a series of tutorials page that will have important for you focus on MySQL, the library of an SQL database that we will in these two boxes, a single record, a single item, and a type of data for each column. It's all the information that a library columns here as we would like. I'll do this to make our first table to understand the idea of a schema. However, just to and then so we just page. Let's go ahead now. 5 and then clearly 36. We're going to go into a little bit more detail with the things we can do when creating our schema. It all starts with the create table command. So in this tutorial, we'll look at the types of options we have when creating tables and some of the control we have when defining the structure of our data. We'll create a new table now. So create a table, and this time we'll call it product. I made a small mistake in the last tutorial. I gave the table name a plural name for this. Something else like a not null, which is actually all the inserts column there. When we work with the Android Room library, we will be able to use just a couple more things now that we can do when defining our tables and giving our data some structure. Product will in a number, so we're good, and then everything will be fine. SQLite. We've covered the primary key, which you can set on an integer type, and that will give you an automatic number. So to put all the schema, and then, which will help make it really clear what's going on with Android Room. So let's dive straight into getting the Android Room library set up in our project. We Google search for Android Room library, and then search. And you may get a few links, but the one that I'm interested in is the one that's android.com/training. I can see here this result save data in a local database using Room, which is exactly what we want. This first page here gives a nice overview of what Room is, how to set it up. For those of you who don't already know, Android Room is the current best way to manage a local database in your app. We can see in this paragraph here, the Room persistence library provides an abstraction layer over SQLite. Just breaking that down a little bit. By saying it's an abstraction layer, what it's saying is it's an easy way to get an SQLite database set up and start interacting with it. For example, the previous tutorials where we create tables and all of the commands we need to do and remember to do that properly, you're going to see in a couple of tutorials' time how easy the Room library makes that. So that's what it means by abstraction layer. The things that we deal with in Android will not be as difficult and as complex and cumbersome as dealing with SQLite directly, which is fantastic. And it says there, allowing fluent database access, the way that we put things in and get things out, it's going to feel very natural to us in Kotlin and in our Android projects. It's going to take away a lot of the boilerplate setup that we would have normally had to do if we were using SQLite directly. So the Room library is absolutely fantastic. We'll head now down to the setup section, and there's a whole heap of things here. Make sure yours is on the Kotlin tab rather than Groovy if you're using the build.gradle.kts file. If you're using the old just build.gradle file, you would use the Groovy version, but we'll use this one. And the things that we're going to need, well, they're defining the version as a variable, val room version once, and you can see that that variable is then used in all of the various dependencies that we might need. So we will need the first two, the room runtime, but also this second one that says annotation processor. So a slightly different keyword for our dependency there. We'll get into annotations in just a moment. And then, this is the important part and the focus of this tutorial, we need to use one of the two annotation processing tools. So either CAPT, K-A-P-T, standing for Kotlin Annotation Processing Tool, or the newer, better and faster KSP, Kotlin Symbol Processing. We'll get to this in just a moment. So we will copy those 2 lines there. We will use one of the annotation processors. We'll be going for KSP, as you'll see shortly. And the only one of the optional libraries that I'm interested in is the top one that says Kotlin extensions and coroutine support. We will be doing coroutines later in the course, and even before we do that, there may be some useful extension functions that we can use. So this is a good optional one to add. We won't be using any of the other words that you see here. So we can actually go ahead and copy from the version at the top down to the first optional dependency for the Kotlin extensions and coroutines. And we'll be deleting one of these 2 annotation processors. You don't need both. So we'll copy all of that, head to Android Studio, and I've just got 2 files loaded. I've got the project level build.gradle file, so that one there that says build.gradle brackets get it done, and then I have the one that's inside the app folder there. You can see in brackets :app. So in the app one, we will go to the very bottom where the dependencies are, and we will add these dependencies. I'll make some line breaks after the implementation lines, and I'll put all of the Room stuff in here. In fact, I'll do a quick comment to say Room dependencies so I know, and I'll paste those all in. We have our Room version. The runtime, that's mostly for the code that we write. We have this annotation processor, and we'll get onto annotations very shortly. And then we need a tool to actually process the annotations, either capt or KSP. And you can see right now that they're both red. It's not a term that's available to us, so we need to set up one of these 2 things. Let's actually go ahead and remove the capt dependency. We won't actually be using that one. We'll do best practice and keep things modern and use the currently recommended faster KSP. I'll leave the 2 comments in for now. So this is for Kotlin symbol processing, our annotation symbols. Let's head back to the documentation. As mentioned, we are going to be using lots of annotations when setting up our various things in Room. To show you what I mean, I will scroll down a little bit to some of the sample implementation. Okay. Take, for example, this first thing, a data entity, and we will go into details about what an entity is in a couple of tutorials' time. But you can see in this data class for a user, there's quite a few annotations. One that says @entity, that's an annotation, and that's for the whole user data class. And then for each of the constructor properties, we've got @primaryKey, @columnInfo. If we go down a bit further to the data access object that we'll be learning after that, we can see @DAO, @query, @insert. And for the database itself, we can see @database. So for the database, the data access object, and the entities, all of which we'll be covering in detail, so don't worry too much about these terms just yet, but we can see that the Room library makes heavy use of these annotations. And what are these annotations? Well, as the word would suggest, they're markers we can put on various things, like a marker on an interface, or a marker on a class, or a marker on a constructor property. And these are for compile time. So when we compile the app, meaning we press build and it takes all of our code and makes it into a working app, the Room library will look for these annotations, and then it will know what to do to convert this, a plain, simple data class that we've used many times before, into something that makes sense for SQLite. That's what takes all of the pain away. And I'm going to be showing you not only how to create these different things, entities, data access objects, but I'll be showing you where in Android Studio you can see the generated code, the generated SQLite that these annotations make. But it is the annotations that make the whole thing so simple. But in order for these annotations to go from just a simple marker to actually generating code at compile time, when the app builds, we need two things. Just heading back to Android Studio. Well, we need this annotation processor library. So this is a version of Room, the Room compiler. So when the app is building, this library will know exactly what entity, primary key, query means. That's what this dependency is for. But even before we can use that, we actually need some kind of Kotlin tool that even knows how to process these annotations at all. And that's where either KSP or CAPT comes in. You have to choose one of these tools to even be able to process the annotations at all. So we will get KSP, the newer one, set up right now. So back to a browser. In a new tab, I'm going to do a quick search for Android KSP setup. And this top link says migrate from CAPT to KSP. KSP is the newer way of doing it, it's recommended. So this link will be just fine. Even though we haven't set up CAPT before, we should find what we need within here. So clicking on this, CAPT, the Kotlin annotation processing tool, the older version, allows you to use Java annotation processors with Kotlin code, even if those processors don't have specific support for Kotlin. So this is a tool for using Java annotations and making it work in Kotlin world. But if we read down, KSP, Kotlin symbol processing, is a Kotlin first alternative to CAPT. KSP analyzes Kotlin code directly, which is up to 2 times faster. So it is an absolute no-brainer to use KSP rather than CAPT. So we'll scroll down, get it quickly set up, and then we can forget all about it and crack on with using Room. This is a one-time setup. So 2 things we need to add. We need to add the plugin at the project level. So this is the build.gradle.kts file at the project. And we have this line here. Strange looking thing, making sure it's on Kotlin, not Groovy. Okay, this line here, but with a very specific and strange looking version, and we'll get to this in just a moment. But let's copy this line, and this goes in the project build file. So in the project one there, underneath these 2 lines, I'll paste this. So that's the plugin we're installing, and then once we have this line here, it then allows the second line, which is this one, id com.google.devtools.ksp. By having the line in the project file, we're then allowed to apply it in the app build.gradle file. So I'll copy that and paste that at the very top where it says plugins under the application and Android plugin. Okay. But we need to change the version. And the way the version works is the first part needs to match the version of Kotlin we are running, which is here. So for me, it's 1.9.0. For you, it might be slightly different. So whatever version of Kotlin you have here, we need a version of the plugin that starts with the same version. So I'm going to go back to the documentation. And I can see here, you can find a list of releases on the KSP GitHub page. So I will click this link. And then I can see all the versions here. And the first part is the version of Kotlin. So I need to search. So find a release for 1.9.0 and search. And then scroll down until I can find 1.9.0. Okay, there we go. And usually it's best to get the most recent second version. So 1.9.0 is our version of Kotlin, hyphen, and then it's the version of KSP. So I want 1.9.0 hyphen 1.0. I know that might seem strange, but you must match the Kotlin symbol processor with the version of Kotlin. So I have 1.9.0 Kotlin, and I have a version of the KSP that is built for Kotlin 1.9.0. I'm applying the plugin in the app build.gradle file, and when I click sync now, this red bit of text, because the KSP function isn't available yet, should suddenly become available to us. So let's click sync now. And then you can see we now have access to the KSP. So this Room compiler dependency is specifically for the Kotlin symbol processor. So this strange KSP thing, this dependency, and the annotation processor you see here, it all works together to make sense of these things here, these annotations. The Kotlin symbol processor will be able to process them, and the specific Room compiler libraries within the annotation processor and within that KSP function will convert it into the correct code for us. So I know that's quite a lot of information for not much progress in terms of our setup, but I've not seen many tutorials where people really explain much about these annotations. They're just markers, a shorthand, so that when you press build or compile, it can take what we've written, our data class, and it can use the annotations, these markers, to produce a very specific auto-generated code for SQLite. And that takes a little bit of extra first-time setup. To recap, we must first, at the project level, give access to the KSP plug build file, the KSP function, just like implement